I want to take a pretty close look at this scenario, which you're going to see a lot. It's a scenario where you've got two triangles, one's inside the other, and you're told that the triangles are similar. If they're similar, we could say that corresponding angles are congruent, so we could say that ACB is congruent to AED, and we could also say that this angle up here, angle D, is going to be congruent to the angle it corresponds to, angle ABC. Now, using either one of those pairs of corresponding angles, this and this, or this and this, we could use the corresponding angles converse to say that line segment BC is parallel to line segment DE. So, whenever we have the parallel line inside the triangle, we're going to be able to use the triangle proportionality theorem. And one thing I want to show you, though, is I want to call attention to when you can and when you cannot use the triangle proportionality theorem. So if we drop some numbers in here, you're going to be able to use the triangle proportionality theorem to solve for x here. You could say something like 3 is to 6 as 3.5 is to x, and that's going to work to get you x. But the problem is you're not going to be able to use the triangle proportionality theorem to solve for y. So let's take a look at this in a little more depth. You might want to copy this image down so we could do a little bit of work to figure out how we're going to solve for x and y. So we've already talked a little bit about how we know that in this scenario BC is going to be parallel to DE, but if you remember that when we have parallel lines inside a triangle, we can use the triangle proportionality theorem, which is going to let us say something like 3 is to 6 as 3.5 is to x. We're going to go down the sides of the triangle. 3 goes with 6, and then we could go this way and say 3.5 is to x. So if we cross multiply here, we get 3x equals 21, and we divide by 3 and we get x equals 7, and it's pretty easy to use the triangle proportionality theorem. Unfortunately, we're not going to be able to use the triangle proportionality theorem when we solve for y. So to solve for y, the first thing we're going to probably want to do is write a statement of proportionality so that we can fill into it. Let's also try to visualize these triangles separately. We've got the smaller triangle and we've got the bigger triangle. Let's steal some information from the triangle above. We know that AC has a value of x. We know that AB has a value of 6. We know that AC has a value of 4. We know that AB has a value of 6 plus 3, which is 9. We know that DE has a value of y, and we know that AE has a value of x plus 3.5. So we could take all that information and fill it into the statement of proportionality, and now we've got everything that we need to solve for y. So let's ignore this part of the proportion because it doesn't help us right. And to solve for y, you can just use this part of the proportion over here. And then you could say something like 6 times y equals 36. So y is equal to 6. And you're done. So another thing that you could do, though, once you have all this information down, is you could just write a proportion. You could say 6 is to 9 as 4 is to y as x is to x plus 3 plus 5, x plus 3.5. Once you have all of this information laid out, like organized, you may not need the statement of proportionality, although it does help keep everything organized and help keep you from making mistakes. I was having some pretty serious computer problems trying to make this video, so if the whole thing is a little start and stop, that's probably why.